Okay guys, welcome back to math class. Today what we're going to do is the SAGE review or the Aspire review, whatever you want to call it. We're going to be doing units 3 through 6. So SAGE review number 2, units 3 through 6 and 8. In this video, we're just going to be doing units 3 and 4. So unit 3 and 4, that's the first page. The second page is right here. Okay, so we're going to skip everything. We're not going to do that one, 6, because that's in unit 6. So we're just going to do the first 2 pages, and that way we can cut it up a little bit. We don't have this big, long video. All right, let's make sure we are focused. I think we're good there. We can see the whole board. Awesome. Okay, so we're starting right from the top with this top question. This is 3A. So this is one of the first things when we start getting into polynomials. And I kind of already went a little crazy with this problem, just to get it set it up correctly. Because the way it's set up on your paper is kind of weird. We've got this. This is the first polynomial, and then minus like just a question mark. And that's kind of what we're solving for here. And then we didn't have room for it, so it says equals all this on the bottom, and I wrote all that off to the side over here. So really what I did to get from this line down to here is I decided I wanted to get what we're solving for, which is this question mark. I wanted that on one side by itself. So I moved that over to the right by adding a question mark on both sides. So in doing that, now that goes away here on the left. And on the right, we have it by itself, because then what we did next is we took everything that was on the right here, and that's what it looks like. It's on the second line here of your packet. And I just subtracted that by both sides, or subtracted both sides by that, rather, okay? So what happens is question mark goes away, appears over there, and then this polynomial just zeroes out on this side, and we brought it over here because we did minus this whole polynomial on both sides, okay? So that's the main first step here to solve this. The next thing we're going to do is distribute this negative through each of these terms, and then we're going to kind of add like terms here. We've done this before, you guys, okay? So when I distribute the negative, this is positive, so this is now going to become negative. I've got a minus 2x squared, so 2 negatives makes this positive. Again, negative 10x, so negative and negative makes this positive. Negative 7, 2 negatives, this goes positive, and now this can go away. We distributed our negatives, so we're in good shape here. Okay, and so now, really, these are all lined up on top of each other, so this is kind of straightforward. All we have to do is now we're just adding them together, okay? So negative 5x to the third, positive 5x to the third, that's going to be 0x to the third. So really, this is going to go away. We're not going to have an x to the third in our answer. 4x squared plus 2x squared, 4 plus 2 is 6, so 6x squared. And remember guys, we're not multiplying together, so that's why the x squared, that's kind of like I've called it like our indicator in class. That's the indicator that these are like terms, so we're just adding the coefficients and the x to the second power stays the same, okay? Same principle here, we've got positive 10x and negative 8x, 10 minus 8 basically, so that's going to be plus 2x. And then this is just 7 minus 6, so that's going to be plus 1, okay? So really, because I said this is going to go away, so I'm actually just going to erase it. And our answer is going to be right here. It's going to be 6x squared plus 2x plus 1. Okay, so that's the first question. That was right here, 3A. So remember, you guys, as we're doing these, I want you guys to be doing what's on the other side over there, okay? So that's what you're going to do on your own, and you're going to turn that in. And turn it in, what I mean when I say that is you're going to email it to me, figure out a way. I think you can turn it in on Canvas. Some people have been doing that. So however you can get it to me is going to work out all right. Okay, so what we've got next here, let me just double check, make sure we can see this on our screen, and yes, we can. Okay, so this is the second problem. This is right here, and obviously there's a little hint because you saw my work, but what we're doing here is a box. And at this point, really, this is what we've been doing all year, so this should be pretty fresh. At this point, we have 3 terms here, 1, 2, 3. So I'm going to go 2x squared minus 4x plus 5. And then off to the side, I've got x plus 3, okay? So x plus 3. And really, the thing to remember here is this is positive x, and this is positive 2x squared, okay? So now we're multiplying everything into the box. I know we've done a lot of factoring things out of the box, but when we have things on the outside, we're multiplying to get into the box, okay? So 2x squared times x is going to be 2x to the third, because remember, this is like 1x. So x times x squared gives us x to the third. 2 times 1 is 2. Same exact principle here. Negative 4x times 1x. X times x is going to be x to the second power. Negative 4 times 1 is going to be negative 4, okay? Same thing here, we've got 5 times 1x, so this is going to be 5x. And then we go to the bottom row and we're doing the same thing. 2 times 3 is 6. And because there's no x here, what we see with the x's here is going to stay the same. So there's no x here, so it's really just x squared times 1 kind of, so 6x squared. Same thing here, 3 times negative 4 is negative 12x. And then 5 times 3 is positive 15. Okay, so now we take our terms out of the box and we combine our like terms, okay? So I can see that my like terms kind of are here, these are like terms, and here, these are also like terms. So we could combine them immediately, but we'll just write all the terms out because that's what we've done in class before, and then we'll combine them at that point. Okay, so I'm just going to write the terms as I see them. And I'm going to write like I'm going to do this one, and then this one, then this one, and then this one. Okay, so 2x to the third plus 6x squared minus 4x squared. And then I can do either of these in order, it doesn't really matter. Minus 12x plus 5x plus 15. Okay, and so now our like terms, like we just identified, they're these two and these two. Okay, so this stays the same. This is 2x to the third. 6 minus 4 is going to be 2x squared. Minus 12x plus 5x is going to be minus 7x because negative 12 plus 5 is negative 7. And then the 15 stays the same. So this is our answer. Let's double check it. 2x to the third plus 2x squared minus 7x plus 15. This is what we are looking for, okay? So I hope we're all kind of remembering that a little bit now. So what we're going to move on to, I'm going to erase what's on the board there, and we're going to move on to 4B, the two 4B problems. And again, this is like how we started to learn to factor. So this is not necessarily factoring with the box like we've gotten used to with quadratics and everything. This is going to be factoring using the greatest common factor and then using factor by grouping. So those were like kind of like the first stepping stones, I guess you could say, to when we started learning factoring. So we'll erase this real quick. I hope you guys are all doing all right. I think something I'm going to do in a future video is come up with like third quarter awards or something like that. And with your third quarter award, and maybe there'll only be like 10 of them, I'll come up with categories of things. And with those awards, I'm going to give you guys fourth quarter extra credit, just based on the kids I saw that really did a good job in third quarter. And it's not necessarily just going to be the kids that like crushed it all the way through. It's going to be kids that improved, kids that just like certain miscellaneous things. I don't know. I'm going to come up with some stuff and make it fun, okay? So we'll move on to 4B now. So we're on this 4B problem, still on the front page of Sage Review number 2, okay? So factor the equation. This is our first 4B, and it looks like this. 5x to the third y plus 10x squared y squared minus 25xy to the third. Okay, and the way that we did this when we very first learned factoring, kind of just like the bare bones of it, was we took each of these three terms and we kind of segmented them, and we just wrote down all the factors for those terms, okay? So for 5x to the third y, we'll just write that again right here, x to the third y. The only factors for the number here are 1 and 5. Okay, so 1 and 5. And then I have 3 x's, so 1, 2, 3, and then a single y. Okay, same thing, we're going to do the same principle here. This is 10x to the second power, y to the second power. So the factors for 10 are going to be 1 and 10, and then 2 and 5. And then I have x to the second power, so there's 2 x's, y to the second power, so there's 2 y's. Okay, awesome. Now the last one we're going to do over here, we're doing the same thing. We've got a minus, and the negative doesn't really matter for factoring. It does matter in the scope of the whole problem, but it doesn't matter for factoring this 25. So this is negative 25x y to the third. So really we're just thinking of the factors of 25 because it's going to be the same as the factors for negative 25. So 1, 25. And then again, if I were to just go through my list, 25 divided by 2, that doesn't work. I get a decimal. Divided by 3, decimal. Divided by 4, that's a decimal. 25 divided by 5 is our other one that works. So 5 and 5. Okay, perfect. We're not quite done yet, though. We have a single x, and we have 3 y's, y to the third power. It's y times y times y. Okay, so now to pull out the greatest common factor, what we have to do is identify the biggest number that appears on all 3 lists here, and then also the biggest number of variables we can take out, okay? So we'll start over here. The biggest number is 5, okay? So I've got 5 here, 5 here, and 5 here. That's perfect. So I'm going to circle those. 5, 5, and 5. And if we were to go and we were to try to find a bigger factor, it doesn't matter if we pick any number out of these two because it's not going to appear over here. So 5 is the biggest number for our smallest polynomial value. So that's the one we're going to have to use, okay? So now if we go to our x's, I have 3 x's here, 2 x's here, and a single x here. And the same principle applies here where I can only take out a single x, okay? So I take out this one for all 3. I can take out 1x for all 3. Same exact principle for y. There's a single y here, so I can only take out 1y for all 3. So now what we've done is we've essentially, what we've got circled, 5xy, 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 that's our greatest common factor, okay? So GCF equals 5xy. So the last step here is we're going to use the box again. We're going to put all these terms in the box, and then we're going to backwards factor out of the box, and that will give us pretty much what will be our answer, okay? So we're going to have our box like this, and we have 3 terms, so we're going to have 3 boxes. Greatest common factor comes out here, 5xy. And then the 3 terms we started with in the beginning go inside the box. So 5x to the 3rd y, positive 10 x squared y squared, and then negative 25 xy to the 3rd. Okay, and so now what we're doing is we're dividing, we're taking each of these terms and we're dividing, so we'll start like right here. Divide this by this. 5 divided by 5 is 1, so I'm going to put that up there. X to the 2nd power, or I'm sorry, x to the 3rd power divided by x is going to be x to the 2nd power, because remember our polynomial rules, or I guess I should say our exponent rules, x to the 3rd divided by x to the 1st, well, we think of that as x to the power of 3 minus 1. So that gives us x to the 2nd power, okay? So to the 3rd divided by x, that's x to the 2nd. And then y divided by y, remember y divided by y just goes away. That just equals 1, so we don't even need to worry about it. So this is what we're going to have first. We're going to do the same exact logic for doing 10x to the squared y squared divided by 5xy. 10 divided by 5 is 2. X squared divided by x is just a single x left over. Y squared divided by y, just a single y left over, okay? And then over here, it's negative 25 divided by 5. So this is where the negative comes into play. I'm going to have the negative 25 divided by 5 is 5, okay? So negative 5, and then x divided by x, that goes away. Like x divided by x is just 1, 5 times 1 is 5, so we just keep the 5. Y to the 3rd power divided by y, that's going to be y to the 2nd power, okay? So essentially what we've done here is we have taken our original polynomial, we found the greatest common factor, we divided it out, and now we have kind of 2 things multiplied together, and that's going to be what our answer looks like. So our answer is going to be down here. We're going to have 5xy, and then x squared plus, because this is plus 2xy, minus 5y squared. And that is our answer here, okay? All right, now on to the next 4B problem. We're almost to the first page here. And again, I'm kind of just flying through, or at least it feels like I am, because you guys can pause the videos and all, like I've talked about in previous videos, so, you know, I don't need to worry about, like, who normally naps? Who naps in first period? I don't need to worry about, like, Jaden and Jaime getting on their phones or whatever. You know what I'm talking about. You guys can pause your video, do what you got to do, get back to it at your own pace, okay? All right, 4B. So again, this is the very last problem. This is going to be factor by grouping, okay? So this one's a little tricky, but once I start doing it, you're probably going to remember pretty quick, okay? So I've got 7x to the 3rd minus 5x squared minus 42x plus 30. Okay, so with factor by grouping, the really nice thing is we have 1, 2, 3, 4 terms. And when we do our normal 2 by 2 box, we have 1, 2, 3, 4 boxes. So I can just put the terms in the boxes straight up. 7x to the 3rd minus 5x squared minus 42x plus 30. Okay? And so now we know how to factor out of a box. We're going to do the same principle we did down here, doing this divided by that to get that. We're going to do kind of the same thing here. But we have to start by factoring out greatest common factors for each box, okay? So we're going to start with this top row. What's the biggest common factor between 7 and 5? Well, it's just 1, okay? So I'm going to have 1, And then the biggest number of x's, again, so this is like if I were to list all the x's for here, I would have 1, 2, 3. If I listed all the x's here, I would have 1, 2. So because there's 2 of them for each, I can factor out 2 x's. So this is x to the second power. I hope that makes sense to everybody. All right, now down here, this one's a little trickier because 42 and 30 are going to have a number that's a greatest common factor. So because you guys are doing this at home, you can even, if you just Google like greatest common factor solver or something, like I bet one of the first results is going to be something just like in the calculator, how we learned to press math right 9. And in your calculator, then it would pull up something where you could just put in the numbers and it'll give you the greatest common factor. I'm going to tell you right now, just to save time, the greatest common factor with 42 and 30 is 6. Okay, so I can take out a 6 here. And if you need an explanation on that, let me know in the comments or send me a message or whatever, and I'll do the math for you there. Okay, so now we're going to do the same thing that we do with the rows with the columns. So the biggest number, the greatest common factor number, again, is going to be, it's going to be 7 actually this time. It's not going to be 6, it'll be 7. The biggest number of x's I can take out is just 1. Okay, now here the biggest number factor we can take out is going to be 5. And there's no x's we can take out, okay, because 30 doesn't have an x to give, so that's why we don't have an x here and we don't have an x here. So now the tricky thing is we have negatives on the corners here. And one of the things that we just learned in class, it's got to be on your notes back in Unit 4, is that when we have negatives on the corners, this comes negative and this becomes negative, okay? So now this is our answer. We're going to have 1x squared minus 6, which is just the same as x squared minus 6, multiplied by 7x minus 5. And that is it. Okay, so that is Unit 3 and 4. Do we have more? We do have more. Yeah, no, we're not quite done yet. We've got 4 more problems to do, you guys. I'm hoping these are going to kind of go quick. We're 16 minutes in, so I'm going to sort of just power through, try to be done by the 25-minute mark. Okay. All right, so now we're on to the second page. And this is just our normal factoring problems, okay? So 4C is going to be a normal factoring one. 3D, we're kind of going back to using imaginary numbers I. 3C is going to be another factoring into the box. And then 4A is going to be our exponent rules. Okay, just a quick review of exponent rules. So this 4C one, I'm going to fly through this one because this is what we've been doing for like the last couple months in class. We're just factoring this straight up. So this is x squared minus 7x plus 12, and this is a quadratic. So we go through this one with our step-by-step process of putting our first term here, x squared, our third term goes here, we multiply across, we get 12x squared, okay? Now we find all the factors for 12, 1 and 12. 12 divided by 2 is 6, 12 divided by 3 is 4, those are all of our factors for 12. Okay, because 12 is positive here, we end up putting a plus sign between the two. Okay, this gives us 13, 8, and 7. And what we're looking for here is this. So we have a negative 7, and we've got positive 7 here. So we're good on this, we want this, but we want it to be negative. And we make it negative by just multiplying everything by negative 1. We can do that, that works. Okay, so this is good. Now I'm going to put this here as negative 3x. I'm going to put this here as negative 4x. Okay, I can explain why the x's are there. It has to do with how the x is here, and I just didn't write it in these terms, basically. It's kind of what's going on. So I factor the top row, I get x. Bottom row, I get 4. First column, I get x. Second column, I get 3. And again, we have our negatives in the corners. So I go negative, negative, and now this is factored as x minus 3 times x minus 4. And that is our answer. Okay, on to the next. Now, 3D. So 3D, we're multiplying into the box, okay? So we've got this. We have 4 minus 6i times 2 minus 9i. Okay, so for 4 minus 6i, that's going to go up here. 2 minus 9i off to the side. Okay, so now we're just multiplying into the box, all right? 4 times 2 is 8. Negative 6i times 2, negative 6 times 2 is negative 12i. 4 times negative 9 is negative 36, and we have an I. And then negative 9 times negative 6 is going to be positive, hold on a second, positive 54, I'm pretty sure. Yeah, 54. Yep, and then I times I is going to be I to the second power. Okay, so now we're going to pull everything out of our box, and we're going to combine like terms. Okay, so I'll pull everything out down here. This is going to be 8 minus 12i minus 36i plus 54i squared. Okay, and let's remember the trick with I. What I really is I equals the square root of negative 1. It's an imaginary number. So with that logic, I've got I to the second power is going to be, well, the square root of negative 1 to the second power is just negative 1. Okay, so I've got I to the second power, I'm going to plug in negative 1. So we're going to do 2 steps going from this row to the next one. We're going to combine those like terms, and we're going to substitute I to the second power for negative 1. Okay, so I've got 8 minus 12 and 36 gives us 48i. And then plus 54 times negative 1. Remember, we just plugged in I squared. We basically took this. It's equal to that, so I plugged it in like that, okay? So now this is going to be negative 54 plus 8, which is going to be negative 46 minus 48i, and that's our answer. Okay, because really what we did here is we turned this into negative 54. Okay, and again, any questions on these videos, post a comment. I know some people have written to me saying they're confused about things. I'm always happy to answer your guys' questions in any way possible. If I get enough questions, then I'll go through and I'll do like a whole video with everybody's questions, okay? So now our last problem here, oh, we've got 2 more. What time are we at? Hopefully we're not. And remember guys, this is like a whole, oh yeah, we're crushing it. 21 minutes, we're good. What we're doing with these reviews is this is basically what we would do over the course of like a whole class. So the fact that we can get through half of this review in 25 minutes, I think that means we're doing pretty good. And this second review is definitely the longest. Okay, it's 4 pages. We're gonna get to the third review, which is a lot of graphing, so that should not be too bad. Okay, let's just double check, make sure we're looking good. The smudges look a lot better on the camera than they do in real life. It's kind of nice. Okay, so 3C. Now this one's tricky because this has to do with our square roots, okay? Multiplying numbers with square roots. So we have negative 7 times the square root of 2 minus 6 times square root of 2 minus 5. Okay, so again, whenever we see it like this, we know we're multiplying into the box. So I'm going to put negative 7 square root of 2 and then negative 6. Positive square root of 2. And we can even think of this as like 1 square root of 2 minus 5. Okay, so the rule for multiplying square roots is the numbers on the outside get multiplied together and the numbers on the inside get multiplied together. You have to do them separate, okay? So 1 times negative 7 is going to be negative 7. The square root of 2 times the square root of 2 is the square root of 4. Okay, negative 6 times 1 is going to be negative 6. And then this stays the same. It's kind of, you can sort of think of it like a variable. So negative 6 square root of 2. Okay, negative 7 times negative 5 is going to give us positive 35, because 2 negatives give us positive. So 35 square root of 2. And then negative 5 times negative 6 gives us positive 30. Okay, this is looking pretty good. So now what we got to do is pull everything out and then combine like terms and see if we can simplify any of our square roots. Okay, so I'm going to go to negative 7 square root of 4 minus 6 square root of 2 plus 35 square root of 2 plus 30. Okay, so the trick with combining like terms with square roots is if the number in the square root, like these two, is the same, then you can combine the outside coefficients just as if it were a variable, like if this was just like an x. If this was x and x, we could combine these two numbers. The same rule works here. Okay, so we can combine these two, and because this is just addition, subtraction, we're not like multiplying 6 times 35. We're thinking of them as coefficients. So 35 minus 6 is going to be 29. Okay, so 29 square root of 2. That's 35 minus 6 gives us 29. The square root of 2 is kind of like our indicator. And then we've got a plus 30, that doesn't change. And then we can do one more thing here. 4 is a perfect square, okay? So with 4 being a perfect square, the square root of 4, if I were to do that in a calculator, or if I just in Google put square root of 4, it's going to give us 2. So really this is negative 7 times 2. So we'll do a couple things here. Negative 7 times 2, that's going to give us negative 14. Okay, so this is really negative 14. And then this is plus 29 square root of 2 plus 30. So now I have two like terms here, 30 minus 14. Okay, so if I were to do 30 minus 14 in the calculator, I'm going to get 16. So this is the answer here is going to be 16 plus 29 square root of 2, and that's it. That's our answer for this 3C problem. Okay, we have one more, and I think we're probably close to 25 minutes right now. All right, almost 26 on the nose, that's fine. We're good on that. This is 4A. And this is just our exponent rules, just something we needed to remember from exponent rules. This is n to the 2 over 5 to the power of 1 over 3. Okay, so if you don't remember your exponent rules, that's okay. I had to double check this one, make sure that I was doing it right. Whenever you have an exponent raised to the power of an exponent, which is what this is, then you multiply the two exponents together. So what this really is it's n to the power of 2 over 5 times 1 over 3. And when you're multiplying two fractions, you just multiply the top and you multiply the bottom. So really this is n to the power of 2 times 1 is 2 on top, 5 times 3 is 15 on bottom, okay? That is going to be our answer. All right, so that's it for Sage Review number 2. This one is going to be due, and I'll send out an email with this information as well, but this one, as well as Sage Review number 1, I think I'm gonna have them do like next Wednesday, which is gonna be April 1st, okay, you guys? So if you can just get something to me, either email it or submit something on Canvas, either way, just showing that you've done it, you're gonna get credit for it on fourth quarter's grade. All right, guys? So take care of yourselves, and I'll see you in the next video.